The Pantheon has the largest unreinforced concrete dome on Earth. It's been standing for nearly 2,000 years. Your local sidewalk starts cracking after 20. You'd assume modern engineering beats ancient engineering in every way. Better tools, better science, better materials. Not this time. For centuries, historians and engineers genuinely didn't know why Roman concrete outlasted almost everything built after it. Structures like the Pantheon, ancient Roman harbors, and city walls have survived earthquakes, floods, and 2,000 years of weather that modern concrete simply can't handle. Some Roman seawalls have sat directly in ocean waves for 2 millennia and are, if anything, getting stronger. That last part should stop you cold. Concrete that gets stronger over time sitting in salt water is something modern engineers can't reliably replicate today. So what was the secret? For years, researchers assumed it was the volcanic ash Romans mixed into their concrete, and that's genuinely part of the answer. But it didn't fully explain everything. Scattered throughout ancient Roman concrete samples, researchers kept finding small white mineral chunks called lime clasts. For decades, most scientists dismissed them as a mistake, evidence of sloppy mixing by ancient workers who didn't fully blend their materials. MIT professor Admir Masick found that explanation hard to believe. Masick has said he was fascinated by these lime clasts from the moment he began working with ancient Roman concrete, precisely because modern concrete formulations never contain anything like them. If the Romans put this much effort into building monuments meant to last forever, why would this one component consistently look like a mistake? Here's why that assumption never sat right with him. Roman engineers left behind detailed written instructions about concrete production, specifying exactly which materials to use and how to prepare them. These weren't careless builders, so why would supposedly sloppy mixing mistakes show up consistently across the entire Roman Empire for centuries? In 2023, Masick's team, working with Harvard University and labs in Italy and Switzerland, finally found the answer, and it wasn't a mistake at all. Analyzing 2,000-year-old concrete samples from the ancient site of Privernum, Italy, researchers discovered that Romans used a technique now called hot mixing. Instead of mixing water into lime before combining it with other materials, the standard modern approach, Romans introduced quicklime directly into the mix at extremely high temperatures. That single difference changed everything. This hot mixing process created those small lime clasts on purpose, not by accident. And those clasts turned out to be reservoirs of reactive calcium, essentially tiny repair kits embedded throughout the concrete itself. Here's how it actually works. When a crack eventually forms in Roman concrete, water seeps into it. That water reaches the lime clasts and dissolves the calcium inside them. The dissolved calcium then recrystallizes as calcium carbonate, essentially growing new solid rock directly inside the crack, sealing it shut before it can spread further. The concrete was healing itself, automatically, for 2,000 years. Researchers tested this directly. They took modern concrete samples, deliberately cracked them, and compared two versions, one built using the Roman hot mixing method and one without it. Water just kept flowing straight through the ordinary sample, but in the Roman-style sample, the crack sealed itself within weeks. Think about the implications of that. Every crack that ever formed in a Roman structure over the past 2,000 years had a chance to heal itself before it could spread and cause structural failure. Modern concrete has no equivalent defense. Once it cracks, water gets in, steel reinforcement inside corrodes, and the whole structure begins to fail from the inside out. Consider the scale of what this means for something like the Pantheon. That dome has been exposed to nearly 2 millennia of rain, temperature swings, and structural stress, and yet it still stands without a single piece of steel reinforcement inside it. Modern reinforced concrete structures, by comparison, are often expected to need major intervention within a single human lifetime. Modern infrastructure typically needs major repairs within 50 to 100 years. The Romans built structures still functioning after 2000. Researchers studying this now believe reviving Roman-style hot mixing could genuinely extend the lifespan of modern concrete, while also reducing the carbon footprint of cement production, which currently accounts for a significant share of global emissions. So the next time you walk past a 2,000-year-old Roman ruin still standing strong beside a modern building already cracking, remember this. The ancient world didn't just build things to last. They built things that knew how to heal themselves, and it took modern science nearly 2,000 years to figure out how they actually did it. That gap alone should make you pause. Every year, modern civilization pours billions of tons of concrete, most of it destined to crack, corrode, and require replacement within decades. The Romans solved this problem once, then the knowledge simply disappeared for the better part of 2 millennia, hidden in plain sight inside chunks of lime that everyone assumed were a mistake.